All right. Good evening, everyone. My name is Philip Donlan. I'm a lecturer in chemical engineering, and it's my nice job tonight to be able to formally welcome you all to our Engineering Open Evening. First of all, great to see the numbers that turned out tonight and to kind of feel the enthusiasm out in the room. So again, do make sure that after we finish up today, there is another session to come out and talk to us at the stand. So any questions, anything at all, do make sure to hang around. We'll all be there again afterwards. In the meantime, what we've put together is a panel of speakers who are trying to give you a different perspective on engineering. So we're going to start off with Professor Aoife Ahern, who is the Dean of Engineering and Architecture. And then after Aoife, we're going to have a talk from Nicola Fortune from the UCD Careers Network, and that's going to be giving you a bit of an insight as to how you can manage your career as you go through engineering and how we're going to help you. After that, we have Aaron Gilmartin, who is going to give us the student's perspective. So Aaron is a final year mechanical engineering student with us here. And then last but not least, we have one of our own, Eleanor Thornton, who is a chemical engineering graduate, who is out in industry at the moment and is going to give you the perspective of someone who's gone through the degree, gone through the program, who's out working at the moment, and again, just kind of giving you a flavour of what that's like. So before we kick off, just to get a few kind of housekeeping bits out of the way, if there is any emergency or anything like that, have a look for your nearest fire exit. So you have one to the right, one to the left, and those of you up towards the back, you can see the signs pointing you out the direction there. So if anything does happen, just slowly does it out through the exits. So before we go into our speakers, we're just going to play a quick video for you, which is going to introduce you to to UCD in general, and then after that, over to our speakers. Never works when you want it. Engineering at its finest. There we go.
We're born curious. Curious about the world around us. And curious to find out what we can become. We ask questions and seek answers, constantly challenging ourselves to think bigger, go further, learn more, to discover what's out there, what we can learn, and what we can give back. Because when we open our minds and let loose our imaginations, the scope of what we can achieve is limitless. And all you need to do to start that journey is take the first step. Find your degree at ucd.ie/CAO. UCD. Think bigger.
All right. So we're going to go into our speaking section now. Each of the talks is about 15 minutes. And then at the end of the talks, we're going to have a Q&A session. So as your questions kind of do arise, make sure to kind of take note of them. We'll have a section at the end where we can discuss through with the panel. And then, as I said, after that, we'll all be around to answer any more questions after as well. So that's enough for me. Over to our first speaker, Professor Aoife Ahern.
Just checking if this works. Nope. Okay. So as Philip said, my name is Aoife Ahern, and I'm the College Principal and Dean of Engineering and Architecture here in UCD. And what I'm going to do today is talk to you a little bit about engineering in UCD and also engineering in general. So, sorry, I'm just going to see if we can. Okay. So we have a short video. Same one again. Sorry there. Is it coming to the wrong presentation? There we go. Is that working? So Philip had forgotten to turn this on. And I'm going to get the wrong direction, am I? There we go. A very short video, first of all, to show you about the potential and the different
Will you come with me?
that could happen in engineering.
Across bridges and railways.
To feel the Atlantic's wave power.
To brave new worlds. From the rudder to the engines.
To making monsters.
These things are there for me and you.
From purifying water with reverse osmosis.
To stopping cells dying. from apoptosis.
Multiplayer.
Online.
Gaming.
Clearing minds. And saving lives.
These things are there for me and you.
Chartered engineers, bringing dreams to life for me and you.
Okay, so I think what that video does very briefly is show you an overview of the kind of careers that you can have in engineering and the broadness of engineering, the diversity of engineering. And apologies in advance to any of you who were at the open day in UCD. Some of these slides you'll already have seen, and you may have heard me say some of the things that I'm going to say now before. But what I'm going to talk to you a little bit about is why would you choose to do engineering at UCD? And why this university over other universities? Well, I think there's a lot of reasons to do engineering at UCD. We're ranked up in the top 1% of universities worldwide. We can give you an excellent education. We're the preferred choice on the CAO for engineering. We've fantastic links with major employers, and I think some of you may have talked to our intern managers about the links that we have there. And in UCD as well, you have a lot of opportunities to engage in modules outside of engineering, so to broaden your education and to give you a very diverse kind of broad education as well. And of course, our university and the degrees here in this university are accredited by the different professional organisations, which is really important when you come out as an engineer and want to work abroad and want to work in different types of places. We also have one of the broadest and widest ranges of options of engineering in the country, from biomedical, civil, structural, environmental, electrical, chemical engineering, etc. So we have a huge range of disciplines that you can get involved in. And because we have that entry into first year, or the common entry in first year, you don't have to make that choice until you get to second year. So you get the chance to think about these different disciplines and options as well before you get into the second year. So our format, or the structure that we have to our degree, and maybe one of the students might talk to you a little bit about this later on. Aaron might say to you what it's like to go through a degree like this. If you decide to do engineering in first year, the first thing that you'll encounter in that first year is a broad common entry degree where you'll be working with lots of students and encountering modules from across the engineering disciplines to give you that chance to find out what it is you really like about engineering and which area you want to be in. And that's important because for a lot of you, you might have some ideas of what you think about engineering but not know exactly what it is that attracts you into the area. There's also quite a lot of common modules across science and maths and physics and chemistry as well, because obviously what's really important for an engineer is that you have a good basis in those fundamental sciences and those fundamental mathematics. And one of the questions that we get asked quite a lot at open days like this is, well, I've done physics but I haven't done chemistry, or vice versa. How am I going to find it if I come into engineering? And that's what first year is about, that you get that opportunity to engage in the subjects like maths, physics and chemistry, and that we get to bring you all up to the same level before you go on into the second year. So it can be difficult at times to take up a new subject in first year when others have done it for the Leaving Cert, but it is not impossible, and we are there to help you as much as possible. And most people will be coming in with either physics or chemistry, not both. So there is a big emphasis in first year to making sure that we get you up to the same speed as everybody else before you go into second year. And at that point, you start to look at different options and you start to encounter modules across the different disciplines and get a taste of what engineering is like across those different disciplines, as you can see listed on the slide there. And it's towards around about this time in first year that our students start to get talks from the different disciplines in engineering and start to think about what they want to do in second year. So our students are all coming back next Monday for the first week of the semester, and they'll start to have these talks from across the disciplines at that point, so that over the next few weeks they will make the decision about which of the disciplines they want to go into. And here in UCD we don't operate a quota system, so when you make that choice, you will get to do the option that you choose. Okay, so we don't cut it off that we only have 60 in mechanical or whatever. If you want to do mechanical engineering, you will be able to do mechanical engineering. So then you go into your second year, and in year 2 and 3 you've chosen your pathway, which of the disciplines you want, whether it's biomedical, chemical and bioprocess, civil, etc. One of these different options that you have here. And again, there's choices and pathways that you need to start looking at here in second and third year. You could, for example, opt to stay on and just do a 4-year BE, okay, so that would be a 4-year Bachelor of Engineering, or alternatively, you could say, actually, I'm going to stay on and do the 5-year ME, the 5-year degree, which will lead you to having a BSc, a 3-year BSc, plus the ME after 5 years. And the 5-year ME is your Masters of Engineering. But I think what's important to think about or to look at when you're going through the process, and as you look at the different years, you'll find that each year you start to get more and more specialised. So you start to go, as well as having the breadth of engineering and the breadth of the discipline, you now start to go deeper and deeper into the particular area that you want to work in. And you'll see different choices and more choices coming up as you go through that programme. So the important stuff for those of you now in 5th and 6th year and coming up to doing your leaving cert is what do you need to do? What do you need to get in order to get into engineering here? So the code in the CAO is DN150. The points of our students are between 511 and 625 points. So last year the cut-off point was 511. So obviously we have some very high achieving, very, very excellent students, high quality students in the programme. And you need to have the 6, we take that 6 leaving cert subjects the same as always. And there are certain things in engineering that are different to other subjects. For example, you need to have mathematics, a higher level mathematics with a minimum of a H4. You need to have 1 laboratory science, okay, so that's chemistry, biology or physics, and 2 other recognised subjects. So there are, in addition to the points, there are certain requirements that you must fulfil in order to be able to choose engineering as a discipline in that CAO. And it's very important that you ensure that you have those before you fill in the CAO form and put something down that isn't applicable to you. The subjects, as I've already said, that you study in first year, there's a lot of maths and a lot of science to try to get you the fundamentals there and get everybody up to speed. But you also start to encounter modules across the different disciplines as well, energy engineering, etc., creativity and design, which is in civil engineering, and you will also have options and in-program electives that you can take from outside of engineering. So you can start to look at modules in areas that just interest you. For example, would be very much encouraged that you might think of taking a language to give you the opportunity or better opportunities for working abroad as an engineer. But because of UCD Horizons, you can take modules from outside of engineering as well if you want to. So how do we learn? What kind of teaching do we do in engineering? What are the encounters that you have with us? Well, we range from the very traditional, the lecture, which is, someone standing in front of you and talking to you in the lecture, but also we have laboratories, tutorials, group learning, design work, project work, where you will be in a lab actually having to do experiments, having to write up those experiments and reports, etc., learning how to use equipment, learning how to do data analysis. Our tutorial groups will be where you're working in smaller groups then, looking at working through problems, getting to ask questions, maybe working with postdoctoral students and PhD students on those kind of problems. And as well, from first year onwards, a lot of trying to work in group doing design work and project work. What you'll see though is, and what you'd encounter in engineering as you move through the programme, you'll probably find a greater move or a greater emphasis on that design work, project work as you get towards the latter end of the programme. Okay, so we really want you to take on your own learning and take on responsibility for your own learning as you go through engineering, and not just be sitting writing notes and taking down notes in a lecture, but starting to do and to practice what you're learning as well as an engineer. So the different disciplines, to go through them very quickly, because I'm conscious that there's lots of other speakers straight after me. We have our School of Civil Engineering, where civil engineers are looking at planning, building construction, building infrastructure, developing infrastructure, all very relevant in Ireland today as we try to build an infrastructure to allow our economy to grow. And the kind of areas that they might work in, as you'd expect, are construction, infrastructure and transportation planning. But a big area for civil engineers will be in sustainable development and looking how to develop infrastructure in a way that meets the needs of our society in the future, and that can do that in a sustainable way. Looking at protecting the environment, allowing us to travel more sustainably, looking at trying to manage water and make sure that we have access to clean water systems as well. Also within the School of Civil Engineering, we would have structural engineering with architecture, which is a little bit different to civil engineering. And that's because the emphasis in structural engineering and architecture would be very much on building buildings obviously, and also bridges and other structures as well. So a little bit more focused than the civil engineer, who would be a broader kind of education looking at different areas within civil engineering. And what's very interesting about our structural engineering with architecture program is that in addition to doing structural engineering, you will also take modules with architectural program as well. So you start to learn about how to appreciate the aesthetics of a building, how engineers should be working with architects in teams to develop large projects, etc. And again, they go into a lot of the traditional civil engineering areas of construction management and project management, but also into management consultancy and finance. And you'll see that as a theme across all engineering, that a lot of our engineering graduates, because of the kind of numerical skills, the problem-solving skills that they have, will actually move into disciplines outside of engineering and are highly employable across all kinds of areas. Biomedical engineering is one that seems to be of huge interest to a lot of people nowadays, and is a relatively new kind of discipline when you think about older disciplines like civil or mechanical engineering, but extremely popular amongst students and extremely important nowadays. And this is looking at using traditional engineering methods to solve problems in biology and healthcare, and working with other healthcare professionals to look at how you might improve biological outcomes and medical outcomes and advance healthcare. And again, they end up working in quite a lot of areas, looking at developing medical instruments and devices. And this is a huge industry in Ireland. So there's a lot of opportunities for employment in Ireland within this area, because we have some of the largest corporate companies in the world who look at creating medical devices actually located in this country as well. In our School of Mechanical and Materials Engineering, which is our biggest school in the College of Engineering and Architecture, we have mechanical engineers looking at the design, manufacture, operation and testing of components, and again, working in a huge number of different types of area, looking at energy systems. So again, that link always that engineers have with sustainability, with looking at how we can create a better world, and very pertinent obviously nowadays with that increasing emphasis on sustainability and the environment. So engineering is a career very much motivated towards people who want to work in that area of creating a more sustainable future. Also in mechanics, people looking at robotics, again working in space, but in healthcare, but also in space, and looking at communications and entertainment devices, cars, etc. So mechanical engineers moved away very much from the traditional view of mechanical engineering to much more, many more areas that we might not have thought of before for mechanical engineers. Also within the School of Mechanical and Manufacturing Engineering, we have Energy Systems Engineering, again very, very important nowadays, looking at how we can solve the world's energy problems and how we can create energy in a way that doesn't damage the environment in the way that we've created energy beforehand, and looking at energy electrical systems, transport systems, etc. Okay. Our School of Electrical and Electronic Engineering, so electrical engineering is looking at use of electricity, generation, transmission and final use of electricity in our world. Electronic engineering, however, on the other hand, is more looking at circuits and systems, etc. And both, we have very, very active units in both areas in that school, and our graduates, again, coming out from that area, have a large number of areas which they go into to work in afterwards. And finally, our School of Chemical and Bioprocess Engineering, which Philip is working in. So chemical and bioprocess engineers are interested in looking at transformations, transformation of oil into petrochemicals, etc., and how those transformations can be realised on a large scale. So again, end up working in a lot of different types of areas, and again, much as I said beforehand in relation to the biomedical engineering, in chemical and bioprocess engineering, some of the biggest chemical companies in the world are again located here in Ireland, employing huge numbers of graduates. And I think it would be true to say that in our chemical and bioprocess engineering stream, we probably can't produce enough graduates for the employers out there. But I think across all the disciplines in engineering at the moment, there's a shortage of engineers in the country and a shortage of engineers in the world. So whichever discipline you go into, the opportunities are enormous and very, very exciting for engineers going forward. But in case you don't want to be in Ireland, there are a huge number of opportunities to work abroad afterwards. And also then within the programme, we start to look at whether we can help you to study abroad as well. So in your third year, you have opportunities to go and spend a semester or the full year in one of our partner universities around the world. If you choose that option, we sit down with you, we look at the modules that you would take over in those universities to make sure that you're getting the same kind of learning outcomes, the same kind of learning objectives as you would achieve if you were staying here. And we've identified different universities that we've gone through that exercise with, and so it's really really, really enjoyable and interesting opportunity, not just for the learning that you do in those universities, but for the life experience you get from spending a bit of time in a different country studying. At the same time, if you decide not to go abroad and you decide to stay here in Ireland, in third year you'll find quite a large number of study abroad students coming into your programme here. So again, you get that opportunity to experience interactions with people from lots and lots of different backgrounds in engineering in the third year of the engineering programme. If you stay on and you decide to do the Masters in Engineering, which is the 5-year programme as I mentioned beforehand, what happens in the second half of your fourth year, so this time of the year in January, our fourth years who are going to finish off in the 5-year ME programme are all heading out on work placements. So those work placements run from January through to September. And they are organised, or you are helped to organise those with our intern managers who are both here this evening, who set up interviews or help to set up interviews early on in the very first semester with different companies. And again, we have huge interest and a lot of very, very good relationships with some very big companies, some interesting companies, where we can help to place you in those to work. And you also get paid on many of those internships as well. So we help with the interviews that you do. You spend 6 to 8 months out in your internship. And last year, all our students secured internships in very, very good companies. And what's really important about that internship is many companies use it like an extended interview. So they use it to get to know you and for you to get to know the company. And a lot of our students come back from that internship, coming into their first year in September, with offers of jobs already. Okay, so it's a really, really good way to experience the workplace, but it's also a very, very good way of securing employment for when you finish off engineering as well. And I think this is a very positive part of the programme and one that a lot of the students really, really enjoy when they're going through the programme. Who employs engineering graduates? Well, huge numbers, obviously, of companies employ engineering graduates, from the traditional engineering companies, some of which you will see there, to the financial sector, to the banks, to the big five, to the consultancy companies, all of whom, as I said to you before, like that fact that engineers think differently to other people, that they are problem solvers, that they're analytical, and that they bring those skills into the workplace and approach problems in a different way to maybe accountants do or to other people do in projects. So a lot of our engineering graduates will end up in engineering companies, but equally quite a large number of our engineering graduates end up in lots of different organisations as well. And we have some very prestigious graduates from UCD Engineering working in these companies. For example, the future CEO of BP who takes up his position next month is a graduate of the electrical engineering programme here in UCD. So really the opportunities for you if you do engineering in UCD are enormous. The links that we have in with lots of companies are fantastic as well, but I think also the experience you get here going through our programme is very exciting, and the diversity and range of options and disciplines that you would have here in UCD Engineering are much greater than you might experience in any other university in Ireland in terms of engineering. Okay, I will pass on to the next speaker.
So good afternoon, everybody. My name is Nicola Fortune. I'm based here in UCD in the Careers Network. So I don't have a video, so sorry about that. I'm just going to be talking to you a little bit about just careers in engineering generally. So what's it like at the moment? What's the market like, I suppose? As well as how you can actually start preparing for your future career now. So what we would think is ideally you don't wait until your final year of engineering to suddenly think, what do I want to do? So it's something we want to work on the whole way through, so every year. So just in terms of a very basic kind of what is an engineer, so you can tell I'm not an academic because this is very, very basic, but the way I would actually see engineers, they're very practical people. So when we look at our engineering students, they're the practical students, they have the interest in science, but they want to use the scientific knowledge, they want to turn ideas into reality, so they want to look at real world problems and solve them. So that's the kind of person you might see kind of in class beside you if you're working towards being an engineer. Obviously there's lots of different types of engineers, and I think Aoife's already after going through a few of those there, so these are just some samples. But also there's a lot of mobility in engineering, so there's a lot of crossover mobility. So it's possible sometimes to find yourself years from now working in a job where you're working in the same role as somebody who did a different path. So it can be surprising where it leads you. In terms of engineers, generally speaking, I think it's been mentioned a couple of times that just what you're bringing in at this point in time, but also through the process of becoming an engineer, you're going to develop a huge number of transferable skills. So the whole way through your qualification, you're going to be put in teams and you're going to be working on projects and you're going to be handling kind of problems the whole way through. So you're really going to develop your analytical thinking, you're going to develop your problem-solving thinking. I'm going to assume most of you are quite good at maths, things like that. So obviously there's a lot of different skills that transfer outside of the engineering area and maybe the automatic kind of areas that you might be thinking of working in. So that's partially why I suppose there's a lot of interest in our graduates, not just from engineering companies or from engineering sources, but also in lots of different areas. So we'd see our graduates going into things like management consulting, IT, finance, things like technical sales, operations and logistics. And if you were to think about the type of skills that might make somebody good in these roles or make somebody attractive in these roles, they really are those engineering kind of skills. So again, the communication skills you'll develop as well as kind of those management and organisational skills. So in terms of just what it's been like for the past few years, so obviously the market is quite wonderful at the moment for engineers. I'm sure a lot of you are already fairly familiar with what it's like. So this is just looking at a snapshot of our 2018 graduates, so the most recent figures we'd have. So as you can see, we have less than 5% unemployment, which is considered full employment, kind of in terms of how you look at figures. So the top employers for that year were things like Intel, ESB, Arup, Pfizer. But you do see employers like Accenture, Deloitte. There's a broad range there. So in terms of kind of starting salaries, I know a lot of times students want to know this. So this is kind of a question I got a lot. So I was like, yes, I wanted to know that. So you can see here the starting salary at the moment based on kind of national figures. So this isn't just here. So national figures for a graduate engineer. It was a median salary of 33,750 on last year. So that's, I think, up there with accounting. So they'd be together, the top two. So that would be significantly above a typical graduate starting salary, which is great. It also continues to develop. In terms of the employment market, certainly it's very, very positive. Most recruiters we're talking to say they plan to continue to grow and are continuously looking for engineers. So there is a shortage across all the disciplines. So it's not which one should I go into because I want a job. They're all fantastic for employability. So it really should be which one do you think you'll be most successful at because it's a good fit for you, because the employability is positive across the board. So that being said, we don't want our engineers to get complacent and think it's an easy market, so I don't need to do anything. Obviously, we want everyone to be as competitive as possible. So by actually taking steps to ensure that you are preparing for your career and making yourself as employable as possible, it means that you're going to have your pick of different options and you're going to find yourself in a role that you actually really want to be in instead of falling into something. So that's where we're talking about trying to make yourself as competitive as possible the whole way through your degree. So, and that starts out in first year and actually today. So that's what I want to talk about for just the next couple of minutes, which is how you can actually start preparing for your career just from the very first day. So in terms of, I suppose, the perfect applicant, you're going to come out of I suppose 3, 5 years, 4 years time, you're going to come out of UCD with a qualification in engineering. You're going to be going applying for jobs. Everybody else that is applying for the same jobs also has that qualification in engineering probably, if it's something relevant. So we want a little bit more than that. So what we're looking for is academic achievement, so obviously to be doing quite well, so academic achievement, but also to have some real world experience. So ideally as you go through your qualification, you might be doing things like maybe you have a part-time job, work shadowing, maybe you have an opportunity to do internships during the summer. So things like that. It can also be things like volunteering. So just gaining some real world experience will make you more employable. Through various activities including work experience or getting involved in societies or getting involved in different things in UCD, developing those transferable skills. So again, when you're talking to employers, they're looking for people with certainly qualifications, but also specific skills. So they're looking for somebody who's good at doing things like communicating with people or who's good at working in a team. Part of what people are looking for as well is somebody who actually really understands the role of the sector. So when you come out of here, ideally, you'll already have spent quite a bit of time doing your research. That's both kind of maybe online as well as talking to people working in different sectors, as well as gaining kind of an understanding by doing things like work shadowing. So ideally, you'll already have had a chance to understand what kind of roles you're applying for before you're at that stage. So, and again, doing things like the academic internships or summer internships gives you a chance to actually find out what jobs are really like and seeing what would be a best fit for you. And then just kind of being engaged with the community. So it's obviously that could be the UCD community or your local community. So it's great to get involved in things beyond just your course. So ideally we'd see kind of that well-rounded person coming out of our courses as opposed to somebody who just studies all the time. So we do want a little bit more life than that. So from the very start, you can start doing things like joining clubs and societies. So there's something like 240 different clubs and societies on campus. Might be even more than that now. So that's everything from the Harry Potter Society to trampolining to Alexoc. So there's definitely something of interest to you there. You'll have different opportunities at the very start. You're probably not going to be doing internships in first year, but you might be doing some volunteering in anything. It doesn't have to be related directly to your course. You might be doing things like work shadowing. You might be doing things like having a part-time job. Even if it's not directly in engineering, you're gaining really important transferable skills, and you're learning a little bit about how work works, so what it's like to be out there. I think, as we mentioned also, doing things like considering learning languages. So you'll have opportunities to take electives. So from the very start, if you are somebody who has that interest, it's something that you can start pursuing from first year. So maybe taking some modules as you go along. At this point in time, people probably aren't thinking too much about it, but ideally in first year, we want you to, from the very start paying attention to what you like and what you don't like, reflecting on your experiences, thinking about different skills that you're developing and which ones you enjoy using, actually thinking about the different experiences you're having and how they line up with your own interests. So paying a bit of attention to what you're actually enjoying the most, as well as doing some research just in terms of careers. So that would be kind of the earliest stages. As you move through, might be a little bit more on purpose, I suppose, so it might quite as general, it might be a little bit more focused. So we'll have different employer events taking place all through your time here at UCD. You can obviously attend them in first year if you want to, or second year, the whole way through. But really starting to attend employer events, starting to attend careers workshops, so for instance, interview skills or presentation skills or how to use LinkedIn, different things like that. Starting to research how the graduate recruitment market works, starting to do things like going to our recruitment fairs in the very early stages, so you're not waiting till the very end and you kind of already know how things work by the time you need to know. Doing things like networking, so both online and offline. So some of that networking will just be doing things like joining the professional bodies that we talk about. It'll be doing things like, again, LinkedIn workshops, starting to develop a bit of an online profile, but also doing internships and things like that. It's all part of building your network. So it doesn't have to be this big kind of, I'm networking today. It's more, I suppose, thinking a little bit about how you can build your network in a more natural way. Again, joining those professional bodies, doing internships, work shadowing. Sometimes it's hard to find an internship as a first year, but it might be a lot easier to actually do something like work shadow somebody for a day and see what are they doing. Then as you're going into second year and third year, maybe you're looking at doing things like summer internships, so that can be very interesting as well. So that could be to try out something that maybe you think you want to do, to see is it really something that you want to do. So internships are incredibly useful because obviously sometimes you'll do an internship and you'll discover that you absolutely love the job and you'll get a job offer and that's all sorted. Sometimes you'll do an internship and you'll discover you hate the job and it's absolutely not what you thought at all, and that's actually really useful learning as well, because that means that you can actually take that knowledge and apply it and you can move towards a different direction. So coming towards the final stages of your degree, what we'd expect to see is our students have already done a lot of this work, so they're really ready to just kind of take action. So at that stage, you've already done things like attend CV workshops and kind of got your CV checked and all that kind of thing, and you're ready to just make sure everything's up to date and really reflects you as you are at that point in time. You'll already have done things like hopefully interview workshops and stuff, so at this point it might be doing things like mock interviews, so practicing for actual interviews. Attending those graduate employer events at this point. So again, there'd be things like an employer could come to campus, they'd give a talk about what it's like to work in their particular company. So this is my company, this is what I do every day, a typical day is like this, these are our opportunities. So again, these employer talks give you a real insight into different companies. And again, you're just going to be ready to actually apply for whether it's graduate jobs or postgraduate opportunities at this point. So we don't want to put all of the work at the very end, we want to build it the whole way through your degree. So as you're going through that, obviously you're not going to be doing all of this alone. So there are a lot of different resources and supports available on campus. So some of them are very general. So for instance, we do have a lot of opportunities available for you. So things like attending those recruitment fairs. So we have very large recruitment fairs, 4 of them during the year. We have employer presentations on campus all year round. We're number 1 in Ireland for employability, just generally as well. So that's something to factor in there. Using supports like the Careers Network. So I'm working in the Careers Network. We do things like we'll have those workshops, we'll have those meetings, but also we have vacancy portals, things like that. If you are going to be doing the ME programme, there's, as I've mentioned already, a lot of support available through our academic internship managers to find that academic internship. But if you're doing a non-academic internship, again, you can come to the Careers Network and we'll work with you to find those opportunities and to be successful in your application. But as well as those kind of very careers-focused things, there's an awful lot of opportunities on campus that will just allow you to develop as a person, and it will impact your career in other ways. So that is doing things like joining a society in first year, and then maybe in second year being a little bit more active and kind of helping with events, and maybe in third year you want to join the committee of the society. So kind of developing those ways, you're really learning a lot about yourself, but also about kind of, I suppose, what it's like to be in those roles, to be in kind of those positions. So these are just some of the opportunities available on campus and some of the resources. I think I'm under the 15 minutes, so I'm going to leave it there now. I'm going to be outside afterwards, so if anyone wants to come up and have a chat, feel free after the session, but I'm going to hand it over to, I think, my next speaker at this stage.
Hi everyone, my name is Aaron Gilmartin and I'm a final year student specialising in mechanical engineering. So I guess why engineering and why I went for engineering. I was very confused in leaving cert. I wanted to do business, science, engineering, and I guess the reason I chose engineering is it's a very flexible degree. A lot of people come into engineering, they end up becoming chartered accountants, management consultants. I have family members that have gone on to become pilots. So it's a very flexible degree. The other thing is, I looked around at some of the world's top CEOs. So the CEO of Amazon, for example, Jeff Bezos, he did engineering. So I was like, wouldn't mind being the world's richest man. So I think as well, there's a lot you might hear sometimes about startup that's spin out of university, especially around biomedical. That happens in UCD as well, and it really starts off with your lecturers. Your lecturers do research all the time. So we do some amazing stuff in UCD, like especially around the biomedical sector. Job opportunities, I hear they're good, so salary looks not too bad, and the practical aspect of it. So I really like the likes of DCG, metalwork in secondary school. Engineering is no different. You know, we do labs all the time. It's very hands-on. We're always creating prototypes, 3D printing and stuff. And they're my leaving cert subjects up there. A lot of them were tailored towards engineering. I did the likes of maths, applied maths, physics, DCG, but honestly, don't worry about it. Everyone in first year is brought up to the same speed. So why UCD then? I guess you might get some ads or hear them on the TV and stuff about it's a global university, and I didn't really get what that meant. But a lot of international students from all over the world come to study in UCD. So there's a really good cultural mix from day one in your degree. As well, there's a study abroad opportunities in year 3, so a semester, or you can do the full year. So a lot of my friends went to the likes of Texas, went to Australia, and UCD as well is well regarded from all over the world. So if you want to work abroad after your degree, UCD is a very good name to have in your CV. Just going back to flexibility again, you might notice that you can do from anywhere from 3 to 5 years. So after 3 years, you get a Bachelor of Science. I don't know of any other course in Ireland that offer you a Bachelor of Science after 3 years. So there is some people that do that. I have had some friends that have left after 3 years and have gone into graduate medicine. They're doing masters in Smurfit and finance. They're looking at going into corporate finance and stuff like that. 4 years, which I'm currently doing, and 5 years. That's what the vast majority of people do. I'd say 75% of people do that. And that's the integrated master's route. Another good thing about UCD is it's a common first year. You're not coming in from day one deciding if you want to specialise in mechanical, civil or whatever. You do modules from usually each department throughout the year. So you'll have modules from the chemical engineering department on chemistry. You'll have modules from the civil department in creativity and design. So you're making a more informed choice going into second year. One good thing about UCD, which I didn't realise, but I've just realised from doing different internships throughout the summer, is the importance of IT and learning how to code. Like my coding, it's very dodgy. But I have learnt, and in industry, they really like it, and each job I've ever done, I use an awful lot of code. And I'd say, like all engineers, accountants, I'd say 75% of your time will be spent using Excel. We use Excel on a daily basis. You're taught Excel here in first year. Throughout my time here, I've done MATLAB, Python, C. So you get a good grasp of coding, and my coding has improved. As I said before, electives, I wanted to study business as well, so for my electives, I did them with the Queen's School of Business. So I did electives around financial maths, business analytics, so it makes you a more rounded individual, and employers like that. A lot of people do languages as well, and their ranking also in the top 1% is very important. So a day in a life, that was my timetable just from last semester. It's typically been the same kind of layout from first right through to fourth year, and it's the same across all disciplines. Chemical engineering might have longer labs, but you'll have about 20 hours of lectures. You'll have 3 to 4 hours of labs each week. So labs, you'll go in, they're very practical, hands-on. You're taking results. Then when you finish your lab, you're doing more research, you're analysing those results, you're making conclusions, and then you submit your lab report. It's usually after 2 weeks, and it gets graded and you get feedback. And then you have tutorials as well, so you'll have a lot of tutorials in the likes of math subjects. So it's good if you're stuck on problems and stuff like that. So I just said I'd give you a taster of one of the modules we did. So I did this last semester, it's medical device design. So in engineering, as you'll do an awful lot of lab work. So I don't think I've ever had any module where I've gone into the RDS and sat 100% final exam. A lot of people doing commerce and the likes of law and stuff like that, they do a lot of 100% final exams. So it's nice to go into an exam and say, oh, Joe, I have like 15% out of the labs I've done. So this module, there was an awful lot of continuous assessment, and the final exam was worth 30%. So I guess we were divided up into a group of 7 on day 1, and we were given a problem. So it was based on a Fontan procedure, which is a procedure some kids have to get done when they're oxygen-rich blood and deoxygenated blood mix in our heart. So they insert this kind of conjugate. So I'm not sure that that video works. So we worked with a PhD mentor who helped us throughout the 12 weeks to come up with a solution to try and improve the patient's quality of life. So we'd look at different materials. We did like fluid analysis on MATLAB. This one, we worked very closely with industry. We worked with a surgeon in Crumlin's Children's Hospital, and 2 people in our group got to see open heart surgery. And it was, I guess we were working all throughout the 12 weeks, and I was working up into this presentation. So the judges, just to give you an idea, were from Enterprise Ireland, Nova UCD, and there was a CEO of a startup. So very well regarded. So just, I guess, the books are one thing. It's 4 or 5 years course you'll be doing, so it's important that you enjoy your time while you're here. So I guess one thing, if you're doing engineering, if you do science, if you do commerce, you're looking at courses that have 300 plus students. And I guess I came from a very small school, so I wasn't used to that amount of people. But I guess my best advice would be to go on the class trips or nights out that are organised. So the Engineering Society of VNT, on week 1, class reps organised a trip for us to Prague in first year. So like I'd say I knew the vast majority of my year in first year. Societies as well, you might have heard it being spoken about. There's loads of societies. They'll be all looking for your €2 in first year to sign up. So I was part of the UCD I&E Society. So we looked at investing in stocks, and we did that with Goodbody Stockbrokers. Outside of UCD as well, I've done a bit of work with IASA, it's the Irish Aviation Students Association. So we work to try and promote different careers in aviation. So we've had speakers from aircraft manufacturers, OEMs, stuff like that. And then there's other stuff as well that you get to do, which is a startup weekend. It's happening at the end of this month, which I'm taking part in, and it's in Google, so lots of free food. Okay, so I guess for me, it was very apparent research wasn't what I wanted. So I came to do engineering really to hopefully get a good job and one I wanted. So I'll just give you a taster of some of the stuff I've done throughout summers. So I worked in ESB after first year. So I worked in the commercial department. So we looked at bringing generators onto the grid. So generators, they can be anything from wind farms, PV, biomass. So we do a lot of looking at their plan information, looking at kind of how they can connect to our grid. There's an awful lot of planning involved in it to see can they connect to the ESB's distribution grid, or will they have to connect into the transmission grid that AirGrid have. It all depends on the size of the wind farm or that. It's rather complex. Then you might have heard of recently that the decarbonising of the environment. So you might have heard that power station there in the top left, West Offaly Power, is going to be shut down in the next few years. So we did an awful lot of work, and ESB in general is doing an awful lot of work on how demand and supply is met, because renewable generators, they're very unpredictable. If the wind doesn't blow, unfortunately, there's no electricity coming. So there's an awful lot of research being done in the likes of storage techniques. So that's Turlock Hill up there. Lots of batteries research has been done as well. So then in second year, I did something very different. I worked in PricewaterhouseCoopers, a professional services firm. A lot of you might say it's an accountancy firm, and that's what I thought as well. But it's actually a lot of engineers go down this route, and they work in all those departments. So tax, a lot work in advisory, so they're helping clients, PwC's clients, advising them how they can improve their business and stuff like that. So like when you're an engineer, you know, we understand how a wind farm works, we know what a generator is. So the clients like that we understand their business model. Assurance as well, auditing companies, and risk, which was what I worked in. So everyone in risk, you basically, when you start a graduate contract, you're basically on a route to become a chartered accountant. So you do your ACAs or your ACCA exams. So a lot of people on my team came from STEM backgrounds, so whether it be computer science, engineering, science. So a lot of the Big Four will sponsor you to do your exams, so it'll give you time off. You'll have classes in the evening time. So just want to show you that there is an awful lot of opportunity. Then the summer just gone past, I worked in aviation. So I just said I'd put this photo up there. So that's the Airbus A320 Neo. The likes of Aer Lingus, British Airways, EasyJet, Iberia, Lufthansa, all them operate that plane. It's the short haul plane, although they have a version of it now that does the long haul. So I guess a lot of airlines are growing, they're always investing in new technology, and I guess they have two main ways of doing it. One is they buy the aircraft themselves, or the other way is they lease the aircraft. So about 50% of the world's aircraft fleet is leased. And I worked in an aircraft leasing company in the technical department. So we'd look at a lot of the maintenance of aircraft. Say if an airline customer wanted to change the seats in an aircraft, if they want to change galleys, stuff like that, if they want to insert Wi-Fi. We do a lot of stuff like that. Another thing my department did was we looked at transition of aircraft. So when it's coming off lease and it's moving to a new customer, the new customer might want different ovens, they might want different seats. So a lot of project management. So I think that's one thing you learn in engineering as well. So I just said I'd put up some of the stats there for Ireland. So every 2 seconds, an aircraft managed out of Ireland takes off or lands. 14 of the world's top 15 aircraft leasing companies have operations here, predominantly in Dublin and Shannon, and we have 65% market share. And that is in the medium term, 800 billion, I was saying million today, but it's billion, of aircraft will need to be financed in the next 5 years. So it's kind of scary, and Ireland has a pivotal role in that. So some of you probably be saying I came to study engineering, Aaron, not come and work in ESB and then go to a professional services firm and then go to a bank. Well, I just put up some of the companies people are on placement at the moment. So a lot of them do go to the likes of Medtronic, Pfizer, engineering companies, and then some go to the likes of Accenture and stuff like that, management consultancy. So a lot of my friends are doing that at the moment. They're on placement. That's because they're in the integrated master's route. I chose BE. And I guess the reason I chose that was because I didn't want to go down the chartered engineer route. It just wasn't for me. And the other thing was I'd worked every summer beforehand, so I just wanted to go to industry. So UCD is very flexible, so that's the route I took. I just saw this graph and I thought I could relate. Year one, you come in, everyone has different standards. Some people have done chemistry, some people have done physics. And I guess we are all brought to the same standard at the end of first year. So it's not overly taxing. It's a nice break from the Leaving Cert. There's lots of nights out and stuff like that in first year, so make use of it. Then second year, the material is new to everybody. and stuff starts getting more complex. And unfortunately, the complexity doesn't ease off in third year. You're learning in-depth stuff on all modules. But I think in fourth year, the jigsaw started coming together, and I think the reason for that is around your final year project. So for my final year project, I'm taking out the folders from first, second, and third year. I'm looking at different modules I did around materials, around coding, and I'm using all of them. So I can definitely agree with that upswing and hopefully ready for the job market after that. So just some advice, taking away UCD, taking away engineering out of the equation, is just to ask. Like, I hope a lot of you hang around tonight, speak to people that have done engineering, what they like about it, what they would do differently. If you have any neighbours that are in engineering, ask them about their career, see, is that really what you want to do? The other thing is have an open mind. It's a common first year. The amount of people that come in that have done chemistry for the junior cert absolutely hate it, do not want to study it for leaving cert, but love it then when they come to college and they end up chemical engineers. That's typical. I came in wanting to do elec, and I think the vast majority of people will always change. Clubs and societies, you're here for 4 years, so enjoy your time here. The peer mentor, so you usually are paired up with your peer mentor the week before you start college. And this was kind of very important to me because I came from the country. I didn't know anyone in my course, so it was a group of 10 of us. Our peer mentor brought us around UCD, showed us the lecture theatre, showed us how to get our timetable. And it was when I went into a big lecture theatre, I knew people, and then they introduced me to other people. So that is very important. There is DEBs and stuff on that time of year, but if you can go to it, I would definitely advise. Just around services UCD offer, just around career services, Math Support Centre, use them. They're all there for your benefit. And just at the end of the day, it's your decision. If people say you should do medicine and you don't want to do it, do what you're most comfortable with, because you'll be doing this for the next probably 40 years. I don't think we're taking questions, but I'll be around at the end, so if anyone has, just ask.
Thank you. Hi everyone, my name is Eleanor, and I'm just going to talk to you a little bit about my path in UCD and what I'm doing now. So first of all, I did chemical and bioprocess engineering here in UCD. I did the 4-year BE and then the 1-year masters. But before I get into why I chose engineering, chemical engineering, and what I'm doing now, I'm just going to give you a little bit of background about me. So I'm from Mayo. When I was 17, I moved up to Dublin. Had only been here for very sad occasions before that. When I was small, I was a big girly girl. I loved pink, I loved dolls, I loved Barbies. I had all the houses, all the cars. And as I was getting older, I was kind of thinking, God, this house could do with a bit of an extension. A sunroom, started building all my own bits with Lego and Jenga and everything I could find around the house. So I think everyone knew I should do engineering before I did. But I really didn't know what I wanted to do for a long, long time. As you can see from my subjects up there, I hadn't done physics or applied maths. I loved accounting, I loved French. In all my work experiences, I went to a veterinary's office, I went to an architect's, I went to an accountant's. And then when kind of the time came to decide what I wanted to do, I kind of narrowed it down fairly quickly to science and engineering, but I didn't really know which one to pick. And it was evenings like this, going to these, asking questions, speaking to people who had done the course, which kind of moulded what I wanted to do. And in the end, I chose engineering because I felt like it was a bit more practical than science. It was a bit more hands-on and industry-based. I felt like there was a lot you could do from it, and it didn't really narrow you. So it was a good platform degree that you could do a lot from. So why did I pick UCD? This has kind of been said before, but it's the best in Ireland for engineering. I also liked the fact that it had a huge range of branches. So not many schools, not many colleges in Ireland have chemical and bioprocess engineering, and that had been on my mind at the very start. So it was definitely something I wanted to target, so I knew UCD has that. But I also liked the fact that they did have the general first year. So you could try every single stream and then make a more informed decision. Another big pull for me was the fact that you could do electives. So I got to do French, I got to do Spanish, I did food, diet and health, I got to do an information studies class. So you get to try things that are totally outside your discipline, which isn't something you get to do in a lot of other colleges. So why did I choose chemical engineering? So you choose your stream at the end of first year. I had always in my head thought I wanted to do chemical and bioprocess engineering, and when we had done the taster classes then in first year, it was the one I liked the most. But I definitely think it was when I went in first year, I was thinking, oh, I'm definitely picking chemical engineering. But when I got to try, for instance, electronic engineering, that module, it was something I loved and something I never thought I would have any interest in. So I definitely feel like the general first year let me decide more accurately what I wanted to do. I popped up the definition of chemical engineering there, a branch of engineering that uses principles of chemistry, physics, maths, biology and economics to efficiently use, produce, design, transport and transform energy and materials. When I tell people I study chemical engineering or I'm working as a chemical engineer, a lot of people say, oh, you must love chemistry or you must love inorganic and organic chemistry. But in actual fact, you don't actually, I think, do much core chemistry classes after second year. Most of what we do is kind of more based in physical chemistry, maths and physics. So an example of some of the classes that I had done in my time in UCD would have been transport phenomena. So I'm looking at my lecture right now. So that would have been like fluid mechanics, heat transfer, mass transfer. We did thermodynamics, and then we kind of built that. You build up those skills each year, so it kind of gets more and more complicated. We did kind of process control, and then we did a lot of kind of design classes as well and research. So you get a broad kind of range of classes, and there's a lot of different avenues then you can go into. One of the things I loved about chemical engineering here was that the class size was really small. In hindsight, it's something I see as so beneficial, but maybe going into it, I wouldn't have seen it as a benefit. But the fact that there was only, I think, maybe 40 people in my class, and also every single class you do is just with that class, whereas for other streams, you're kind of mixed in and out with elec and mech. But for chem, you're purely with your own class. So everyone gets to know each other very well, and then because of that, because you're only with chems, you get to know your lecturers very well. So they're very approachable. So it's just a really nice atmosphere in the School of Chemical Engineering. It's a mix of kind of individual and group work, and we had lots of different interesting projects. I'm actually going to touch on them now, just to give you an idea of some of the different things that we did. So the first one under smaller projects, when we went into second year, our first kind of big project was to design a heart and lung machine. So a lot of these actual projects, and I was going back and reading them, they sound very biology based, but for example, the heart and lung machine wasn't so much about looking at biology, it was more so looking at the system and thinking, how are we going to pump this around? How are we going to make sure that our blood is at the right temperature? How are we going to make sure it has enough oxygen? So looking at spargers and that types of things. And we kind of used things that we had been learning in class. So if we had been doing heat transfer in class, we then went to our project and was looking at heat transfer and how we were going to keep the blood at the right temperature. So that was our first kind of big project in second year, but the two main projects in the degree is in your final year. So that's your design project and your research project. So these are the two projects that I did. So for design, that's a group project. So mine was design a plant to produce L-phenylalanine and L-aspartic acid. It's a bit of a mouthful. And that's a mix of a group. So in your group, you do things like you actually cost, you plan, you look at the kind of environmental side of things, and then as an individual, you get to look at the process and pick out a piece of equipment and then actually go ahead and design that. So it's a really interesting project because you get a really broad, you're not just looking at one thing and designing it, you get to look at every single aspect of design. Then for research, so that's kind of like our thesis. So that covers your whole final year. And for chemical engineering, you can either do that in industry or you can do it in UCD. So I chose to do it in UCD, and I ended up then going to NIBRT, so the National Institute of Bioprocessing Research and Design, and that was my title there. So I was using cells to create a protein and trying to develop that process on a small scale. So I was in a lab, and it was something I'd never done before. I'd never really worked in a lab before, so it was kind of a new skill set that I got to learn. And it showed me that I definitely did not want to do a PhD, but it's as good to cross things off your list as it is to kind of tick them. So junior year abroad in third year, so you get the opportunity to go abroad. I've just shown the US here, but it's a global, you can go anywhere globally. So they're really, really highly ranked universities. You can choose to go for a semester or a year. and I got to go to Texas. So I just wanted to talk about this for a little bit. So I got to go for the full year. UT Austin is ranked number 3 in the US for chemical engineering, so it's really, really highly ranked. And it was a chance to kind of experience a whole new academic side of things and also a different kind of culture. So I'd never been to the US before. I got to travel around everywhere. I got to do different classes I probably never would have got the chance to do. So I did basketball, and I'm only 5'2", so it was comical for everyone watching. I got to do a science outreach class, so I got to go to an elementary school once a week and teach science. I've also got to do a huge amount after that because of the friends I made there. So I travelled to Japan last year. I travelled to Argentina this summer to visit people. So it's not just that year that it's confined to. You get to do so much from it, and it really gives you a huge understanding, both culturally, soft skills, and everything like that. So interning. So interning is a really, really vital part, I suppose, of the course here. So a lot of people who do the 3-year or 4-year course end up doing summer internships. And then if you choose to do the Masters, you get to do a 9-month placement. For chemical engineering, you can actually extend that out to a full year's placement, and you can include then your research project in that. So I ended up doing both a summer placement and then my Masters internship in the same company. So that was a pharmaceutical company called AbbVie in Sligo. So they pharma as opposed to biopharma. So the pharma company means that they create drugs through chemical synthesis. So they're like all your tablets. It's like your Panadol and your paracetamol and that kind of thing. So I was there for 9 months, and it really enabled. A lot of people say you don't use what you learnt in college in the workplace, but that was completely inaccurate for me. So everything, I was whipping out my notes every evening trying to remember what pump was being used or what heat exchanger was happening. So definitely it developed a huge technical learning during my time there, and it showed me that that's kind of the avenue that I wanted to go into, that I knew I wanted to go into, kind of pharma, biopharma and that kind of thing. And as well, it kind of showed how important soft skills are, which sometimes isn't something that you learn in college. So how important your communication and your teamwork and being in a multidisciplinary team is. So job opportunities from chemical engineering. Most people in my class would have went into pharma and biopharma. And that's because Ireland has such a huge amount of companies. So we have all the top 10 pharma companies. We're the 7th biggest exporter of pharmaceuticals, I think. There's over 90 manufacturing sites, so there's loads and loads of opportunities. So I think, I'm not sure about the percentage, but most of the class would have went into pharma and biopharma companies in Dublin and Cork. But if that's not what you like, there are also a huge number of other opportunities. So you can go into design, which is if a company came to a design house and say they asked them, we want to make this site and we want to make this, the design company would design that plant. You can go into oil and gas, food and drink, so like Glanbia, Diageo, Jameson. A couple of people in the class also went into accounting. One of the boys went into stock trading, and then of course there's the option to do research or a PhD or something like that. So where am I now? So I'm in Bristol Myers Squibb, or BMS. So I just started the engineering graduate programme there in September. So it's a 27-month programme and it's 3 9-month rotations. And a lot of the pharma companies have a graduate programme like that. It'll be 3 different rotations, so you get to go to different departments and see which one suits you or you like or you don't like, and then you can kind of decide exactly what route you want to go after that. So this is the site I'm on. I thought it was kind of an interesting slide. So BMS is a global company, but this is their Irish site in Cruisewath and Blanchardstown. It's a really new site. It only started being built in 2015. And I just wanted to give you an idea of the scale of biopharma. So as you can see, there's 6 15,000 litre bioreactors. So a lot of people, when they think of chemical engineers, think you're always in the lab, but that's not the case at all. Most people are actually in manufacturing. So every day I go in and I gown into these kind of blue pyjamas and go onto the manufacturing floor. And because it's such a new plant, and because there's so many new plants being built in Ireland for pharma, a lot of the technology is state of the art. So you're getting to see the top of the range technology globally in Ireland. I just wanted to talk a little bit about the kind of things you're doing at work and what you're actually making. So we're making a biologic, and it's focus area is immuno-oncology, so that's where your immune system is used to fight the cancer. So it would be in contrast to something like chemo, where chemo will go in and kill every single cell. So in this case, you'd be more targeted, so you just target the cancer cells and you won't target any other of your healthy cells. And so that's what I make on site right now, so it's kind of nice as well. It's to go into work and feel like you're actually doing something that's going to make a tangible difference. So what do I do on kind of a day-to-day basis? So right now I'm in downstream manufacturing. Sorry, I didn't actually explain what biopharma was, but in case anyone doesn't know, it's basically where you use a biologic to create your product. So in this case, you're using a cell and you're growing that up to create a protein. So that's called upstream biologics. And then there's downstream biologics where I am, which is where you take that protein and you separate it and you purify it. So right now, I'm on the manufacturing floor most of the time, which is nice. You're not kind of stuck at a desk. So most of the time, you're kind of gowned in. You have your hairnet on and your glasses on and you're all in your pyjamas every day, going around all the pieces of equipment. You're there if anything goes wrong, trying to kind of troubleshoot. And then another kind of thing that you can do from chemical engineering, which is what I'm hoping to do next, is automation engineering. And that was something I never would have thought I would have liked. So that's where you use use a system to automate the process. So it'd be a little bit of coding and kind of looking into the actual process and making sure all of your parameters are set correctly. So that would be much more desk-based, and that's where I'm hoping to go. And that's actually something I never would have thought I'd liked, and I knew I liked it because I had done my internship. So doing an internship is so beneficial in the sense that you can see you really like something and you know that's where you want to go, and if you don't, you can totally change direction. So yeah, I just wanted to finish with what I would have liked to have heard if I was sitting where you are right now. The first thing was not to worry too much about your leaving cert subjects. I hadn't done physics or applied maths, and I was so worried when I was coming into engineering, was I going to be able to keep up? And people as well in chemical engineering who hadn't done chemistry were a bit worried, but they bring you up to speed so quick. There's help from every angle, so it's not something to worry about at all. Also, a general first year is so helpful. Sometimes people want to dive straight into a 4-year course. They want to just go mechanical, but the first year is so helpful because it doesn't pigeonhole you into any one thing. You can try lots of different taster classes and then make your decision based on that. Say yes to every opportunity. So if you get the chance to study abroad, to do an internship, to get involved in projects, electives, do every single thing that you can do because it will benefit you in the long run. And finally, I hope I've shown that engineering is really broad, diverse, and there are so many opportunities. Thank you.
All right. So first of all, thank you very much to our speakers. I think we got a great kind of range of different perspectives on what engineering is as a whole, what you do as you go through it, and then potentially what it might look like afterwards. So we have a bit of time now where we're going to make our panel available to answer some questions. So again, as we're going through, I hope you're kind of maybe taking a couple notes on things that you might want to put to our panel. So I'm just going to open up the floor to see if there's any questions that anyone would like to ask any one of our speakers today. Yeah.
Yeah. So I am from Dublin, and renting in Dublin is extortionate. So I actually thought it was in and around the same living-wise because it was much cheaper to live over there. Your only extra expenses were maybe your flights, but on the whole, other than flights, it was pretty much the same as living in Dublin. And you're paying your normal fees to UCD, so you're not having to pay the American fees or anything. So I definitely found it was in and around the same. A little bit more expensive, obviously, if you want to go travelling when you're there or do other things like that. But on the whole, no, I would say it's fairly even. Pardon, sorry? So Erasmus is like a European programme, so they do all the kind of European colleges, and then if you want to go elsewhere, it's a junior year abroad. So it was part of a junior year abroad, but you apply through UCD. You can put preferences of colleges, and then it's kind of based on your grades from first and second year, and a little kind of you have to write up a few paragraphs, I think.
It's a UCD program rather than so Erasmus is the European Union program for going into Europe. The ones with America and other where are UCD offerings that you can go for.
I'm just wondering, what's the cost of the 5th year to do the master's program?
Okay, I'm not sure the exact cost off the top of my head, but it's about 8,000 euro, isn't it, for that final year? Is that correct today? Okay, perfect. 7,000 to 8,000.
How do you make your choice? How far is
you will make your choice in third year.
No, sorry, for first year, when you do the common first year, you were saying that...
You make it around, so round about now, the students will be coming back and having their talks. They will make their choice between March and April. However, there are always opportunities to change your mind. So there are people who come in September and doing mechanical and think this isn't for me and want to switch to something else. And the earlier you do that, the better, obviously.
With chemical and bioprocess, there is obviously a focus on biopharma in Ireland, but will you learn skills that would be transferable to other focus areas, say other countries, such as chemical manufacturing and stuff?
Yeah, definitely. Okay, go for it. No, you go.
Yeah, so like, I mean, as you go through, you do get the opportunity in third year to take a minor in bioprocessing, but you don't have to do that. So basically the way the degree is set up is we're expecting that you should be completely open at the end of it to working in oil and gas, or working in fine chemicals, any sort of industry at all. We do give the specialization that you can specialize in bioprocessing if you want, if you have that interest. But outside of that, we assume that you should be equally transferable to all industries. So we're not necessarily just training you for that. That just happens to be one very good opportunity which is available in Ireland. And also it is because we are unique in the way that we have a couple of very specialised lecturers in the department that allow us to give that specialisation as well. But you'll be equally as applicable for essentially all chemical industry employment pathways.
Sorry, what is the dropout rate? I heard a very large number quoted earlier.
No, the dropout rate isn't high in engineering actually at all. Yeah. Was that an engineering quote, or was it a quote for dropout of students in general?
It was an engineering quote. It was just obviously it was wrong. So
Yeah. The dropout rates are very low in engineering.
Good to hear.
During the summer for work placement, do you assist the students getting into those work placements?
Not for summer ones. Sorry, good.
So we have different types of internships. So just give an example from our school. So after third year, students often select to go and work for the summer. So that tends to be about a 2.5 to 3 month placement. What we do there is that's not a formal part of their degree, but we'll assist them in any way. So in our roles, we deal with the companies who have places available. They come to us, and we communicate that to the students, and we'd assist with that kind of process. But then once they move on, if they decide to do the masters, the ME that we were talking about, at that point it gets formally directed through the internship managers. And so at that point you're fully looked after from start to finish. So from the moment where we're just telling you what's going on, through to getting the companies engaged, getting the interviews set up, to the point where you're actually you're out of placement. Once you're out on placement, because it's a formal part of your degree, you're assigned an academic supervisor in UCD and an industrial supervisor in the company where you're working. And at all times then, basically just periodic calls, meetings, we always go out on site to visit you. So the answer to your question is yes, we're working with you the whole way through.
Sorry, Philip, on that, I suppose, just to say, so obviously there's some types of internships that are very related to your course and that might be organised through the college and placements like that. But if you want to just apply for an opportunity you see, or if you want to come in and have a talk with the Careers Network about how you'd go about doing it, that would be a central service that's available. So if you want to come in and have a meeting and go, how do I find an internship just in any area, we'd talk to you about that. There'd also be things like CV workshops, interview skills. So there would be those kind of services that you can access the whole way through.
The work shadow.
So for work shadowing, typically it wouldn't be a formal process like that. So there might be, there's different things. So for instance, an insight day would be something where you'd go into a company and it might be a very formal thing where it's an application process. You might send in your CV and do an interview. And you'd go in and you might spend a day or a week finding out about what it's like to work in the area. So that'd be more common, I suppose, in maybe financial services and things like that. Whereas work shadowing, a lot of the time, it's something that's organised through networks. So it's really a matter of maybe somebody knows somebody or kind of reaching out through different people. So work shadowing typically wouldn't be as formal as you know, a placement or anything like that. It's a matter of, I suppose, when you're in your early stages, you probably won't be able to do a lot of work experience because you can't necessarily do the job. So you're kind of following somebody around for the day. So a lot of the time it's about, I suppose, making your case and using your network.
just on all those things is one thing we've kind of seen as well is companies are very, very keen to engage and get you engaged early. From a company's perspective, the earlier they can start working with you in whatever way that looks like, the better for them as well. So like, it typically is a two-way street in terms of we have companies coming to us asking how they can get more involved with you. So if there is someone who has kind of shown an interest in, as I said, getting more experience in a particular industry or a particular company, that opportunity will pretty much always be available. So again, anything that you say to us like that, we're pretty confident we'll be able to type up.
What would be the key difference between a chemical engineering graduate and a chemical sciences graduate?
So again, I think you talked about very nicely about that in terms of like the difference between say science and engineering. So again, the rest of it as an engineer, you're not the chemist, so you're not the person figuring out what chemical needs to be mixed with the other chemical to produce the end result. That is the science graduate. As an engineer, once that discovery has been made, as an engineer, you come in then at that point and work with the chemist to figure out how we can take it from maybe being a reaction in a test tube to being something that we can now scale up to be able to supply the world. So the chemist will figure out A plus B goes to C in a lab. The engineer then will take it from the lab and build a factory that's able to supply the entire world.
Can I ask about research projects? I think Aaron mentioned, particularly in the mechanical engineering side of things, are there exciting research projects happening in the university? Are they hosted by PhD students, or would students on the project program have an opportunity to get involved in any exciting projects that are happening on extracurricular basis, for example?
Yes, so I guess my final year project is around smart technology for old people to assist independent living. So I'm doing that in conjunction with the Smart Lab in UCD. So yeah, there's an awful lot of that. Like I'm reaching out to like industry for stuff for support and help with that. Just say as well with employers, I know a lot of people, especially in the chemical department, their employers help them with their final year projects, and you work with your employer to do research. So yeah, no, there's definitely a lot of stuff like that, and like the stuff like the student management fund, which I mentioned in my presentation, so doing research like that, employers do like to see that. Does that answer your question?
Yeah.
Maybe just add to that, like the schools in engineering are all very, very research intensive, so have very high numbers of PhD students and postdocs. A lot of the time, or wherever possible, those PhD students will be working on PhDs that would result in projects that would be suitable for master's students to get involved in as well. So you might have master's students getting involved in much, much larger projects, but just doing a very small element of that project and feeding into it. So there's huge opportunities there because we are a very, very research intensive university, and the college in particular is an extremely research intensive college within the university across all the disciplines.
What would the time demands be if you're to do an additional elective such as language?
So they're not additional electives, okay? So as part of the program with engineering, you do credits, there's a certain number of credits you have to do each semester to satisfy the requirements for a degree. And within UCD, what's a little bit different here to other universities is some of those electives or credits that you pick can come from outside of the engineering program. So it's not like you're doing them on top of a full engineering workload. These are part of the normal workload, and that's what makes it a little bit different to other universities, to give you that opportunity to do languages, or as you were saying, food and health, etc. People do very, very different things with those electives.
If you're doing a language elective, would you be kind of starting from very kind of basics?
Depends. So it depends on what you choose. So you can choose language electives from kind of the starting point, or you can choose a language electives that build on what you've already done at secondary school as well. And we're really trying to encourage more of our engineering students to take language electives, because traditionally they don't. But it's very important if you want to go and become more international in your career.
Is it possible to get a course or through engineering, be it through workshopping or placement?
So you should talk to, I don't know if you were here beforehand, we have formula students here. They're students who are working across the engineering disciplines, and also some students from outside of engineering and business, etc. And they're working on a project looking at building a car for a race. This year and last year they built an electric car for the first time for the race. And they work with an academic in the college. They're third and fourth years, I think, mostly in that group. And last year they brought it to Silverstone to race in July, and I think this year the race will be in Nuremberg in Germany, obviously. So if they're still here afterwards, you should get an opportunity to talk to them to hear about what they're doing with that project.
How many applications do you receive usually? Last year focused on the 65 days.
Okay, so the numbers of applications, how many people do we get per place available? We get a lot, okay, so our points would kind of give you an idea of where we are. Given that the points were 511 last year, which is quite high, we're oversubscribed for engineering. The number per place I wouldn't be able to tell you, but it is oversubscribed. Yeah. Sorry.
I'm not sorry. No.
Sorry.
Not directly engineering related, but do you have a list of schools, say in the US, that you're partnered with?
Yes. So we have a list of all the colleges that we have sent people to in third year before.
Do you think the points will increase much this year?
Possible to tell. So it always depends. You know, they tend to hover around about the same level each year, so they'll be in the low 500s, I would guess, as well.
Why would you advise students to take a language with engineering?
Okay, I think that it's not something that you have to do. I think it's quite important to do or interesting to do if you want.
Help with like in future,
In the future,
career, or
it can, and it gives you different opportunities as well, and opens up those opportunities that you're not restricted to always working in an English language country. But I think also as well, as companies become more multinational and diverse, that having a language going into work in somewhere like Google or somewhere like that can also be beneficial because those workforces are more international. So I just think as a general part of your education, it's a great idea to do a language and to continue it on rather than saying at the end of your leaving cert, I'll never do another language, I'll never do that again.
Aaron mentioned that he didn't want to go down the chartered engineering route. He's not quite sure what he meant by that.
So in the professional body for engineering in Ireland is Engineers Ireland. Within that, when you first qualify as an engineer, you become a member of the institute, an MIEI, member of the Institute of Engineers Ireland. After that, you would work, a lot of engineers would work to getting something called chartership, which is where you get particular recognition from that professional body, which then is recognised by other engineering professional bodies around the world. To be honest, for some disciplines it's more important than others. So for example, for civil engineers, being chartered is extremely important because you can't sign off on structural designs or construction projects if you haven't got that chartership. For other disciplines it's less important. For chemical engineering, for example, they wouldn't be accredited through that body, they'd be accredited through a different body. So it all depends on where you want to go. If you wanted to work in financial sector or something like that, you might say, well, chartership is something that's not quite so important for me because I'm actually going to be working in an accountancy world or whatever. But it's just basically the professional body's recognition of you as an engineer at a certain level.
Typically comes maybe a couple of years after you've been off working, so you build up a certain body of work on top of your degree, and then you present that as a case to say I've now reached a certain level, and if they agree then you get signed off as having reached that. Do we have any? Starting to.
Is there one question? Right.
I'd say.
Okay. So how many, those horizons, like for example the languages, how many modules can you take from them?
How many electives?
2 or 3 or
You can take 2 a year, 2 electives a year.
Yeah.
Are you talking about just the languages?
no, I'm just talking about anything outside the engineering.
I think it's 2 a year. Yeah.
2 a year.
Well, I think it's first year just because you're just getting to the university.
Because it's quite a busy year, but after that it's 2 a year. Yeah.
What was it in first year again?
1. So first year is a really busy year because, like we've said by several of the speakers today, first year is trying to get you up to speed to all the same level. So it's quite a busy year in terms of what you're doing in the core subjects.
When it comes to your entry subjects, would Ag Science count as your lab science?
No, Ag Science does not count as a lab. Does it? Okay, sorry, my apologies. So Ag Science does count.
And when it comes to the other 2 recognised subjects that you need, is there any particular subjects on the list, or is it just any leaving cert subject?
So the maths, the lab science, and after that, well, you have to have English, obviously, and Irish to pass the Leaving Cert, but it's any subjects after that, yeah.
Students do take in first year.
265 off the CAO, that's increasing this year. What you'll find in first year, I can't see who asked that question, so I'm not going to look at the wrong person. There's around about 300 in first year. This year there were 310.
So there's 265 through the CAO.
That's going up, okay? So the numbers are changing in terms of where they are, but it's been about the 265, 275 off the CAO in the past. It's increasing over the next year or so, but about 310 will be the norm in the first year.
So I think we've kind of got most of our questions out. So what I will say is, first of all, thank you very much for coming and for your attention during the talks. The panel is going to be outside again afterwards along with the stand. So if you have any more questions after this, please do come up and kind of ask us one-on-one. As I said, we'll all be outside in the foyer again for the next while. So while you're here, while everyone's there, make sure to make use of that opportunity. So thank you very much. And